So let's talk about troubleshooting LIN. So that is that's the backbone of the FlexTech system. That's what all the modules use to communicate. So if you have a full system, you have a panel installed, the simplest way to verify that you're not having LIN issues is to look on the gateway panel. That's typically the last module in the chain, right? So you start with PRPC, you'll jump over to, say, an EXP, which may be in the same electrical panel. Then you'll have a LIN harness that runs down the A pillar to an SVB, and finally you jump off the SVB and straight to that gateway panel. So if you look at the panel and the panel's operating, it's responding to park brake. You can set the park brake, you can release it and see that LED, the PB LED change on the panel. You know that LIN is connected and you've got power on the cable. Everything is good there. If the second bullet point there, if you look at the panel and you see that all of the LEDs flashing in unison about once a second, that indicates that the panel is powered, but it has no LIN communication. So you're probably, you're getting 12 volts, 5 volts, and ground on that 4-wire cable I was talking about, the LIN cable, but your LIN wire itself is not getting there. Some things that I've seen taking calls is you might find a screw through a cable in the A pillar. They'll run it down and then they run a screw right through the cable. You're not getting any communication on the system. You can pull the quote codes like I talked about before. If you look at the PRC, you can pull codes and determine what kind of issue you're having. Point A there, a 10, 1, 2. So the fault LED, that red LED is going to flash 10 times, a brief break, 1 time, brief break, and then 2 times. After a full fault code is flashed out, that status LED, the amber LED, is going to flash again to tell you what diagnostic page you're on. So that is going to mark the beginning and also the end of a fault code, right? So that's how you can tell what fault code is being flashed out. Make it a little easier to count those flashes on the fault LED. There's also 10.1.3 if you had 2 SVBs in the system. A 10.1.3 would be no LIN communication with SVB number 2 in the system. A 10.1.4 is no communication with your first expander board in the system. And then 10.1.5 is the second EXP. Most of the systems will typically only have 1 SVB switchbacker board and 1 EXP. That's typically enough for most of the builds. So, you're having a LIN issue with a specific module. In most cases, the issue is going to be one of these 2 things. So either there's a problem with your LIN harnessing, there's a screw through the cable, something like that, or somehow the fuse on the SVB is blown, or you're not getting power or ground to the switchbacker module, and it's not responding to PRPC. If you check, if you're able to verify the LIN connections and the power to the switchbacker board or the EXP module, then you're probably looking at an issue with the module itself. It was damaged in operation or installation. So I was saying earlier that LIN, that single wire serial communication is switching 0 to 12 volts. Depending on the communication on that wire, you're going to see 9 to 10 volts on that cable. So if you want to use a meter to verify that, you can do that as well. So probably easiest to start, you look at the panel's not working. Easiest to start furthest away from the PRPC and work your way back to figure out what section of limb harnessing or what is damaged or broken. And then you can just replace, because it's a kind of a daisy chain configuration, you're jumping module to module, you're going to have a section of limb harnessing that's bad that you can just replace. Or repair. Second scenario we're going to look at is the DLC harness. So possible symptoms of an issue with the DLC harness are absolutely no system function. I mean, this is where the PRPC is getting power. So that's a data link connector harness. So that connects directly to the vehicle's OBD2 port. All functions are based on the communication there. So we'll have a T harness down at the OBD2 port, and then an extension harness that runs up the electrical panel, provides power around PRPC, and then connection to one or possibly two vehicle communication networks CAN. And that's on J19. There's the white 6-pin connector there. So if I grab this module, it's the 6-pin connector J19. So with key and run, you can start at the module itself and start verifying those voltages. You can look for power, make sure you're getting ground, and then verify the CAN voltages there. And if you're not seeing that module, you've got that extension harness. Likelihood is there's some damage to that. So you can run down to the T harness, down to the OBD2 connector, check that, then move to the actual OBD2 connector itself, and verify the voltages there. It's possible that the fuse to the data link connector could be blown as well. So if you have an issue with the PRPC's relay outputs, there's various LED diagnostics that can be done. Obviously, you can do all of it with a meter if you need to, but below I talked about those 4 packages there, dual relay packages, and below them are LEDs for each relay, and they're numbered there. So you can see like 2, 3, 4, 5, 6 right there. But there's LEDs for 1 through 8, all 8 relays, and those are green LEDs. And the green LEDs indicate that the coil of the relay is powered. So they're in parallel with the coil. So if that LED is on, the PRPC is turning that on. I talked about the configuration before. The PRPC is using a configuration that's programmed onto the module, looking at vehicle data, looking at input status, looking at output status, combining those in a logic equation, and then determining if that output should be on. If the green LED is on, you don't even have to think about all the logic behind it. You should be seeing voltage on the output. So contact should be closed at that point. So you can see the fuse up top, the fuse holders. Each of those fuse holders has an LED next to them, a red LED, and that's a fuse blown LED. So if you're not in a diagnostic page, then that's what those LEDs mean. The fuse is blown, right? If it's on, check the fuse, replace it. So if the fuse is on, or the LED is on, that could indicate an issue with the wiring, like a short in the wiring, or maybe there's too much current being drawn out of that output. So the black connectors up at the top, disconnect those, disconnect that harnessing and just put in a scenario where the relay is powered, the green LED is on down below, and then you can start using a meter to verify voltages, so you can check both legs of the fuse, you can check the output pin, see that you're getting 12 volts. So all of those outputs are at 12 volt outputs. Once you verify that the hardware is still functional, you're seeing 12 volts all the way out to the output pin. Fix your harnessing, check for shorts out there, fix all that, reconnect it, and you should be good to go. So there's just a summary of what I just talked about. If there's no voltage on any of the relay output pins, then you may not be getting power to that lug in the center of the board. So the top half of the board is the relays, the bottom half is the logic. J19, that 6-pin connector, that's where the logic, the processor is getting power from. If you have power there, you don't necessarily have power to your relays. The high current power is coming from that lug, and from the 2-pin connector up the top, the saber connector, that's your ground to the relays. There's a number of different configurations for the relays. 1 and 2 and 7 and 8 are similar configurations, so they're just 12 volt outputs. There's another build of the module that allows motor reversing on those outputs. So in the normally closed state, they would be providing ground out on the pin, and you can reverse them, provide ground, run the motor one way, run the motor the other way. So that's 1 and 2, and 7 and 8 can be motor reversing pairs. 3 and 6, you can see there's 2 vertical fuse holders there. Those are not meant to be placed at the same time. It's a fuse stuff option to provide ground or 12 volts on the output pin. If you place both fuses, you're going to blow the fuses. You're connecting power to ground directly. So that allows you to provide a syncing or a sourcing output there. And then 4 and 5, relays 4 and 5, those are split up into multiple fuses. So the single relay output goes to multiple fuses, so you can have different fuse sizes for the outputs. The main purpose of these outputs, you're getting vehicle data and allowing the designer to write these equations, logic equations with inputs, vehicle data, output status, complex logic with very simple wiring, right? So you don't have to go and get all these different vehicle signals, relay logic. You just program it into the model and provide a single output that does what you need it to do. So if you want to do park brake set, transmission in park, and ESS less than 2, you can do it with a single output. You just program it on the model. Talk about the low current outputs. So these outputs are smart FETs, and they have the over temperature, over current protection. So they'll automatically shut off to protect themselves. So diagnostic page 1 shows you the status of those outputs. Basically, it tells you that the result of the logical equation is saying the output should be on. If there's a short on the output or the load current is too high, that output may shut off. And you can see that with a fault code, so that red LED will flash a fault code. So 2.2 tells you there's an issue with a PRPC low current output, and the last number in that 3-digit code tells you which LCO is having the problem. So once a fault is detected, that output stays off for at least 5 seconds, and then it'll retrack. So if you unplug all of the loads from this 8-pin connector down on the lower left, then all of your LCOs, they don't have any load, and you can wait 5 seconds, about 5 seconds, and that output should come back on, and you can check it out with the meter. Once you verify that the output is coming back on and operating, it's functional, you need to fix the wiring or reduce the current draw on that output and plug it back in. So let's talk about how to troubleshoot the inputs on the PRPC. There are 12 inputs. 3 of them, inputs 1 through 3, can be active high or active low depending on the configuration. 4 through 10 are active ground, and the 11th is an analog input. So these are typical voltages that you should see with the inputs not active. The status of the inputs can be checked on diagnostic page 2. So, if you apply a ground to input 4 and you're on diagnostic page 2, the fuse LEDs on page 2 are going to indicate the input status all the way across. So the 4th LED from the left will be input 4. If you apply a ground to input 4 and you're not seeing that LED come on in diagnostic page 2, there could be a hardware issue there. If you are applying a ground directly to the module and seeing that LED come on, then your switch, your interface to the vehicle, some switch, door switch, something's going on there. So you need to fix that. Troubleshooting the LCOs on the SPB is very similar to the LCOs on PRPC, except that your code could be different. You could be having a link communication issue. Maybe your switchback module is not powered, maybe it's not communicating. And you can also check for a fault code. The 6.1 means there's an issue with your low current output, a low current output on that switchback board. And the last number in the 3-digit code is going to be the LCO number. So if there's no fault present, it's possible that we don't completely understand the logic that's required to turn that output on. So we'll need to get the FlexTech configuration, consult that, and make sure that we're getting all of the conditions right for that output to come on. And we'll look at breaking down a configuration. I'll go over a configuration summary and how to break down the logic for an output. Once again, troubleshooting the inputs on the switchback board. Go to PRPC diagnostics page 6. That indicates the status of the inputs on the switchback board. One thing to note, on page 6, the relays on the PRPC are mapped directly to the inputs on the switchbacker. So if you want to bypass the configuration and just test the physical relay on PRPC, that's a good way to do it. I'd probably disconnect the loads from the PRPC relays, go to page 6, then you can actually just ground input and turn on the relay and just measure the voltages, make sure that the hardware is working. Once again, an issue with a switchback board input could be due to link communication issues, could be because the SEB just doesn't have power, or it could be an issue with your switch wiring. EXP also has LEDs that indicate fuse blown. And you can use onboard LEDs to determine if the relay coils are active. If a relay isn't coming on when you think it should be, and you've consulted the configuration, it could be due to lane communication, power to the module, but you may have to go back to configuration and make sure we understand the conditions required. Probably just skip over the LCOs. A different code there. You can see a different fault code for the LCOs, the EXP 81 and the LCO number. PRPC diagnostic page 7 will show you the status of the EXP inputs. So you can apply a ground to those inputs and verify that the corresponding LED is coming on the PRPC. That verifies your link communication, your hardware on the EXP, and then you likely have an issue with your switch wire.